So we will discuss about fluid flow in pipes. So fluid flow in pipes can be broadly classified into two types. One is the laminar flow, in which the fluid flows layer by layer, and another is the turbulent flow, in which the fluid flows in a zigzag manner, creating a lot of eddies like this. And how to distinguish between a laminar flow and a Reynolds turbulent flow? For this, we will look at the famous experiment conducted by Reynold, and we will discuss about Reynolds number. So you can see this experimental setup. You have a beaker in which water is stored, and this water is flowing through this pipe, and there is a valve here, and this valve can be adjusted to control the discharge of water here. And this is a glass tube, that is, you can see the water flowing through the glass tube, and you have a dye container here. This dye container contains dye, and this dye is injected into the water. So this was the experimental setup. So what he did was, the water was flowing through the water through the glass tube, and the dye was injected in the water, and this valve can be controlled to uh, valve can be opened accordingly to control the discharge. That means you can increase the velocity of water through the glass tube. So Reynold observed that when the valve was adjusted, opened, the velocity of water increased, and when the dye was injected for a particular up to a particular velocity, this dye flows smoothly along the water. But when the velocity of water was increased, what happened was that the dye got dispersed. That means the flow became turbulent. Instead of flowing layer by layer, the dye got dispersed, and it was flowing along with the water. So this was what he observed. So this was for a laminar flow. You can see the dye was flowing smoothly along with water without any disturbance. And during a transition flow, when the velocity was increased, when the valve was opened further, so the dye got like this. Dye was flowing like in a wavy fashion. There's the transition phase. And during a turbulent flow, when the valve was opened very much, the dye got dispersed and it was flowing like this. So based on this experiment, he formulated a number, non-dimensional number called Reynolds number. So Reynolds number is defined as the inertia force by viscous force. See, inertia force can be written like this. That is, inertia force actually is equal to rho A into V square. Actually, if you are taking only the dimension, you can write this as A is equal to L square. And for a viscous force, actually, shear stress is equal to mu into V by L. So shear force can be written as tau into area. So this will be area. So area in dimension terms, you can write it as L square. So this will become mu into V into L. Okay, this top you have the inertia force. So the ratio of these two will give you rho VL by mu. This is the Reynolds number. Okay, this is the Reynolds number. So according so Reynolds experiment showed that when Reynolds number is greater than 2000, the flow will become turbulent, and Reynolds number less than 2000, the flow was laminar. Okay, so this was the experiment. So 2000 is the number. So this number is applicable only for a fluid flow in pipe. To classify the flows as laminar and turbulent in a pipe flow only, not in an open channel flow, only for a pipe. This is the number 2000. You need to remember this number.